Welcome to class today, pre-cal students. Hope you guys are doing well. Hope you enjoyed a nice Thanksgiving break, and hopefully you're able to spend time with your families, relax, and enjoy yourself. Unfortunately, it is back to class for you guys today, so let's go ahead and get started right away with some announcements. Let me turn on the Mimeo pad here and we will get started. Announcement number one, there will be a test on Monday. That's this coming Monday. It should be, you said, Mr. Earhart, it's only a week's material. Can we have a quiz instead? Guys, you should want to have a test. That means it'll be a very short test. It only covers 1 week material. And tests, I forget what I have on the spreadsheet. I think your tests are 60 or 50% of your final grade. So be thankful that we're taking a test. You won't have to do it over the weekend. You can come to my house. If you don't want to come to my house, you're welcome to take the test at your own house. That's always an option if you want to. So we will have a test this Monday. If you're not going to show up, I need to know that no later than Sunday. Your integrity sheets. When you walk in the door Monday, I need to know every video you've watched, all the homework that's done, and anything that's not done, you will not be allowed to make up for credit. So please stay on top of your integrity sheets. And then lastly, next to last, I need to hear from some of you on your test still yet. So get these done. Talk to me, email me. I need some communication. You know who you are. And the semester exam is coming up. Now we're going to review a lot for that, so don't worry. I'll make sure you have all the information you need to do well on the test. It'll be your job to study. That's what you have to do on your own, okay? So we have 1 week of new information. We're going to finish chapter 7, so we'll be all done with trig for the entire semester. And then next week we're going to start reviewing for your exam. We'll probably review for about I don't know, 5 or 6, maybe 7 videos, and then I'll give you a couple of days there to take your exam. But I'll give you all of that information later after your test this Monday. Okay, so there we go. Go ahead and grab your notebooks and get ready to take some notes. I'm going to grab a drink of water here. And I will probably be doing that a lot today. My throat's a little raspy, so let's go ahead and get started. Write down your notes, if you would, please. Component form. Component form, lesson 7.6. The date today is the 2nd. I always encourage you to write that down. The date today is the 2nd, and we're looking at a topic called component form. And I guess if you want to make it a little longer, I should have said component form of vectors, because we are going to be talking still about vectors. Okay, so component form of vectors, lesson 7.6, and the date today is the 2nd. Now, it would be, and remember, from here on out I'm going to go pretty fast, so there'll definitely be times where you'll want to pause the video, write things down, and also back it up. It really would be helpful if every vector could be written with the initial point that's the starting point of the vector. It would be helpful if every vector could be written with the initial point at the origin on a coordinate system. Now, if you've forgotten what the origin is, here's your y-axis, here's your x-axis, and right here at 0, 0, we call that the origin. Okay, so it would be very helpful if every vector could be written from right here. And I'm going to show you why it's really helpful later. Okay, let me demonstrate. Let me show you what I mean. In your notes, go ahead and copy this vector down. Here's the initial point. I'm going to put IP. Here's where the vector starts. 2, 2. Here's the terminal point. The terminal point, 4, 6. That's where the vector ends. Well, wouldn't it be nice? I mean, it would be so helpful if we could pick this vector up right here and move it to right here. I mean, remember, that would still be an equivalent vector, right? We should know that. Remember, as long as this line has the same length as the other vector, and as long as it's going the same direction and it has the same slope, then it's the same vector. So to be honest with you, if I could just pick this vector up and move it right here, that would be a really big help. I mean, it really would be. And so that's what we're going to look at today. All right, so please watch what I do here, okay? If I were to pick this vector up right here, now watch what I do. Take some good notes and kind of watch here, okay? If I were to pick this vector up and put it right here, this ending point right here would be 4, 2. All right, over 4 and up 2. Well, Mr. Earhart, how did you know that? I'm going to teach you that in just a second. I'm going to show you where I got that, okay? But here's what I wanted to say to you real quick. And what I want to show you is when you're writing a vector in component form, you're taking it from right here where it used to be, and you're picking it up and you're putting it right over here so that it starts at the origin. That's all you're doing. So right now, I'm going to teach you how to write a vector in component form. And component form just means that we're simply picking up this vector and we're moving it so that the vector is now at the origin. Okay? Now, when a vector is written in such a way that its initial point is at the origin, we call this component form. And I just mentioned that to you about 10 seconds ago, okay? Writing a vector in component form is very easy to do. The formula is simply you take the terminal point and you subtract the initial point. It's that easy, students. You take the terminal point and you subtract the initial point. And once you do that, you have the vector written in component form. That is so cool. Now watch carefully what I'm talking about. Please take some really good notes on this. I would definitely write this in your notes. That's very important. And I would definitely write this formula down saying here's how you write a vector in component form. Now, I would like us to do this problem. I want you to write vector CF in component form. Now, what's the first letter? C. So this is your initial point. C is your initial point. F's the second letter, so F is your terminal point. Now you do not need to graph this. I'm going to try to be a really good teacher that gives you a visual, but you don't have to graph it. Okay, here's your initial point, -4, -3, and then 1 over 1 and up 5 is your terminal point. So there's the vector right there. Now what we're going to do is we're going to pick that vector up and we're going to move it so that it's right here going the same direction and it has the same length. And you don't really need to graph it like I did. I'm just trying to give you a picture of it, okay? All you have to do is take this formula right here and use it. So we take our terminal point, which is 1, 5, right? That's my terminal point, minus the initial point. So minus, and my initial point is -4, -3. That's all we have to do, Mr. Earhart. That's it. And guys, if you're not good with sign numbers, then use your calculator. Okay, you take your x minus your x. So 1 minus -4. Well, that would give you a 5. Okay? And then 5 minus a -3. Well, that would give you an 8. Now, here's how you write vectors in component form. You put an arrow like this and an arrow like this. And whenever you see two numbers written like that, you know that means this is a vector written in component form. So as soon as you see that, you know the vector starts at where? 0, 0, and it ends at where? 5, 8. So 1, 2, 3, 4, 5, 3, 4, 5, 6, 7, 8. Right there. So there we go. And it looks good to me. It looks perfect. So I just picked up this vector right here and I moved it to right here at the origin. That's all that I did. So you took this vector right here and you wrote it in component form. All right, and that's pretty cool. And there it is. So you know when you see a notation like this, an arrow, 5, 8, that means it's a vector that starts at 0, 0 and goes to whatever numbers you have here. In this case, 5, 8. So there you did it. That's all you have to do is subtract the two numbers. Isn't that easy? That's all you have to do, okay? Let's try another one to make sure you really get this. Write vector AF in component form. Write vector AF in component form. Now again, I'm well aware of the fact you don't have to graph this, so please do not take time to do this. If you don't want to, you do not need to graph the vector. I'm just doing it to give you a picture of it, but you don't have to do that. So this is my starting point here, 4, -5. I'm going to put my arrow here. So here's my ending point right up here. Okay, here's my initial point down here, right here. Okay, here's my vector. Now I'm going to pick it up and write it in such a way that it starts at the origin like this, and it goes upward like that. That's my goal. Okay, so remember our formula. This is vector AF, so A is my first letter, that's my initial point. F is your second letter, that's your terminal point. So I take my terminal point, and then I subtract from that the initial point. If you're not good with sign numbers, use your calculator. -2 minus 4, well, that would be -6. 5 minus -5, well, that would be a 10. There we go. This vector right here is the exact same vector as this vector right here. This vector right here is the exact same vector. It's going the same direction, it has the same slope, and it has the same length. So let's go ahead and get a picture of it. 1, 2, 3, 4, 5, 6, 5, 6, 7, 8, 9, 10. So about up here somewhere. So there it is. It starts here at the origin and it goes to -6, 10. There it is. So you took this vector and you wrote it in component form. Alright, one more. I'm just trying to help you guys. I'm not trying to be boring. I just want you to really understand what you're doing. Because once you write a vector, well, you know what we didn't do, and I apologize to you guys. You don't have the best teacher in the world, I know that, but let me go back to this problem here. You should have it in your notes. We didn't find the magnitude. And that's my fault, okay? And it's real important that I show you this because the whole reason we like to write these, or one of the reasons we like to write these vectors in component form, is it's so easy to find the magnitude. Because once you write it at the origin, you really just have a right triangle like this, and you know it's over 5 and up 8, and so using Pythagorean's theorem you can find the magnitude very quickly. So in order to find the magnitude, once you take the vector and write it in component form, please take some notes on this. To find the magnitude, all you have to do is take the square root of 5 squared plus 8 squared, because this is a leg in a right triangle and this is a leg in a right triangle. So if I take the square root of 5 squared plus 8 squared, well, 5 squared is 25 and 8 squared is 64, so 25 plus 64 is 89. So the magnitude would be the square root of 89, the square root of 89. Now let's go to the problem we just finished. We took this vector right here and we wrote it in component form. Once you've written it in component form, I want you to find the magnitude. So here we go. It would be -6 squared plus 10 squared. Well, 6 times 6 is 36. 10 times 10 is 100. So you're going to get the square root of 136. The square root of 136. And that's the magnitude of this vector. Okay, one more and then we'll go on to something else and then we'll be finished for the day. If you think you're grasping this, go ahead and do this on your own. If you want to watch me, that's fine. Okay, we have vector x, y. Here it is. Here's your initial point and here's your terminal point. And I want you to write this vector in component form. In other words, pick it up and write it so that it starts at the origin. And then I want you to find the magnitude. Well, I'm not going to graph this one, but I will say this. In order to write a vector in component form, remember we take the terminal point minus the initial point. All right? Terminal point minus the initial point. Now the terminal point, of course, is -4, -3, and then minus the initial point, which is 0, 6. This is really easy, guys, okay? Put your arrows, -4 minus 0 is -4, and -3 minus 6 is -9. So there, this vector right here is the exact same vector as this vector right here. It's just one of them is not written in component form and the other one is written in component form. In other words, this vector right here starts at where? It starts at 0, 0, and it ends at -4, -9. So there, you wrote the vector in component form. Now I want you to find the magnitude. I want you to find the magnitude, okay? So let's create a little space here. And let's go ahead and find the magnitude. It's the same thing as using Pythagorean's theorem. So I have the square root of -4 squared plus -9 squared, which would be the square root of, well, let's see, -4 times -4 is 16, -9 times -9 is 81. When you add them together, you get 97. So the square root of 97 is the magnitude of this vector. That's pretty simple, guys. It really, really, really is, okay? So let's look at one more quick topic that's actually just as easy as this. Let me get a drink of water here. And I think you'll understand this next part pretty easily, okay? Let's finish up by looking at some vector calculations. These are pretty simple to do, all right? So go ahead and write this down. We're going to use vector u, which is 7, 2, and we're going to use vector v, which is -3, 5. Now, students, do you remember in the last lesson when we were adding vectors, how it was not particularly easy? If you had a vector going this way and a vector going this way, we taught you how to draw a parallelogram. Remember that? And then find the diagonal. Remember that? That was a pain. Well, guess what? Now you're seeing another really, really cool use of writing a vector in component form. Because when you have a vector written in component form, like you do right here and like you do right here, adding, subtracting, and multiplying all of this becomes really, really easy. I mean, really easy. Watch. If I wanted to add vector u plus v, I would simply have 7, 2 plus -3, 5. I'm adding u plus v. And when you add them, well, 7 plus -3 is 4, and 2 plus 5 is 7. Look at that. That sure beats drawing the old parallelogram and finding a diagonal, doesn't it? Writing vectors in component form is amazingly easy, and it's so helpful. It is so helpful. So there, you just added two vectors together. All right, here we go. Let's take a look at u minus 6v. No problem. U would be 7, 2, that's u, and then minus, and then put a 6, and then for v we're going to write -3, 5. Now you should know what to do. You've had enough math along the way. You know you do your multiplication here first. So we would have 7, 2 minus, now be careful here. I guess there's two different ways to do this. I gotta be very careful. I don't know if you, some of you will want to multiply a -6 through. And if you multiply a -6 through, then make sure you put a plus sign here, okay? Some of you would rather leave the negative sign and just multiply the 6 through, and that's what I'm going to do. I'm going to leave the negative sign and just multiply the 6 through. 6 times -3 is -18, and 6 times 5 is 30. There we go. That's easy, guys. So 6 times v, here's u, and here's v. 6 times v gives you this right here. And now finish the problem. Subtract the two vectors. 7 minus a -18. Well, use a calculator if you need to. That's going to be 25. 2 minus 30. Well, that's going to be -28. -28. There we go. Let's move on. This is just not difficult stuff, okay? Next, we have 3u plus 4v. So 3u, that's 3, and then the vector 7, 2, and then positive 4, and then the vector -3, 5. All right? Okay, here we go. Let's first take our 3 and multiply it through our first vector, and if we do that correctly, we're going to get 21, 6. 3 times 7, 3 times 2. And then multiply your 4 through. And when you do that correctly, you'll have negative 12 and a positive 20. And now add your two vectors together. So 21 plus a negative 12, that would give you a 9, positive 9. And 6 plus 20 would give you 26. Again, if you're weak with your signed numbers, your positive and negative numbers, then feel free to use a calculator. That's totally fine. There we go. And now lastly, please don't think, let me grab a quick drink of water here. Please do not think when you see these bars right here that that means absolute value. Remember, in vectors, it means find the magnitude. So we're going to have to take 5 times v. Let me go and get this set up for you. 5 times v, and v is negative 3, 5. And then minus 2u, so minus 2, and then the vector u, 7 comma 2, okay? And then when we're all done finding this, we've got to take the magnitude of this. So what we're going to do is we're going to work this whole entire insides out, if you will, and when we're done, then we're going to find the magnitude, okay? That's what these two lines mean. It means work all this out on the inside, and when you're all done simplifying all this on the inside, then find the magnitude. So here we go. Let's take 5 times our first vector, and we would get a negative 15, 5 times negative 3, and a 25, 5 times 5. I'm going to leave my negative sign here, and I'm going to multiply through by 2. 2 times 7 is 14, and 2 times 2 is 4. Pretty easy. Now let's go ahead and subtract our vectors. Negative 15 minus 14. I'm going to put the answer up here so I have some room to work. Negative 15 minus 14 would be negative 29, and then 25 minus 4 would be 21. So there. You took this information here and you simplified it all the way down to this vector. But unfortunately, that's not your final answer, because remember, we had these bars around it, which means this. I'll put the bars here. That means they want you to find the magnitude of this vector. Well, remember how to do that. When a vector is written in component form, all you have to do is take the square root, and you take your first number, negative 29, and you square it, plus, and take your second number, and you square it. Okay, so if you take a negative 29 and you square it, you're going to get 841. And if you take a 21 and square it, you're going to get 441. And I have someone just about ready to knock on my door. I see them walking up now, so I'm going to pause this video. Okay, so here we go, guys. If you add these two numbers together, you're going to get, let's see here, 1,282. Now, you can take the square root of that number if you would like to. I'm not really being that picky about it. If it's a perfect square, I would like you to go ahead and type that into your calculator. In this case, it's not. If you'll type it in, you'll see you get 35.80502758. So I don't mind you leaving it like this. I would like you to get used to eventually simplifying your radicals. And of course, by simplifying this radical, you would have to see if any perfect squares went into this. Perfect squares would be 4 is a perfect square, 9 is a perfect square, 16 is a perfect square, etc. Okay, but for right now, that's totally good enough for me. I'm not going to lose sleep over that at this point. Okay, so there, we combined these vectors, we multiplied by 5, we multiplied by 2, we subtracted the vectors, and then we found the square root of these numbers here to find the magnitude, and that's all we had to do. Okay, so that's basically it for today. Not a very long video. Now tomorrow's video is going to be a lot longer, so please make sure you're ready for that. Understand that this is the first day back from Thanksgiving break, so I went a little easy on you. So enjoy that. Tomorrow's going to be a longer video, so do understand that, and don't be upset about that, and be ready to work hard tomorrow. Your homework is page 666. That's a real good omen, isn't it? 666. Page 666, numbers 1 through 21 odd. This assignment will not take you a long time, so you're totally good there. Okay, and go ahead and get started. I want you to work on this now. Work on it today. Get it done today. Watch the help video if you need to, and if you don't need to, then check your answers in in the back of the book and make sure they're correct, and the ones that you do not get right, then you can look them up in the help video. Okay, have a good day, and I will talk to you guys tomorrow.